Well, howdy, physics sleuths and inquisitive souls, and welcome again to another lecture in dynamic gravity. So, not to be honest, I wasn't really planning on doing more videos for a while, maybe ever. You know, then I thought, we're like almost in the final year of the Great Tribulation. Not much longer left now until the end of the world, until Putin nukes us all and kills everyone, most everyone. And I thought, you know, I still got a few more episodes I need to teach you guys. We still haven't even been to Other Realm yet. Oh, Other Realm's gonna blow your mind, baby. You're gonna get your mind blown on that one. It's coming. And a few other things in the pipe. But I think I'm gonna start transitioning a little bit here and there from a hardcore geeky physics channel meant to conquer all of the laws of the universe into, also a religious channel where we delve into conquering and understanding and figuring out God. Because, that's just as important. It's good to understand how the world works, like how gravity works, and everything else that I've taught you. But at the end of the day, if you don't know God, what is it all for? It's all for nothing. It's just a waste of life, really. That's better. So, little teaser, what's probably coming. My goal is to try and keep doing videos every few weeks until the end of the world, in about 16 months from now. So let's see if I get there or not. It's coming. But today, magnetic monopoles. What are they? Are they real? Well, once again, as with all things in life, the devil's in the details. And whether or not you can say magnetic monopoles are real depends on your definition of a magnetic monopole. Like anything, you can change the criteria to where something that squarely is now is not. So let's dig in this a little bit, see what we can learn, see if we can't break a little physics today. Hopefully it'll be a short episode, but you know me, I go on and on because I suck. So, magnets, so cool. Take a look at this video.
Clearly see it there.
Where we can clearly see
See the curves, the way it's coming in like two circles from above.
how the field is. This is a magnet, obviously, and you got your field here and your field here. So the north side is probably like one of this side, and this side would be the south side.
And below.
And sometimes it spins round to the other side almost.
So if you get a piece that's sort of on the outer orbit of the ring, it'll come
really
around
cool, though,
straight
right?
to the middle.
There must be a cut-off point where the weight of the iron
It's fascinating.
filing is falling,
Magnets are like
comes round and
magical.
spins round
really
all the way.
crazy.
It must be like 2 inches maybe. Look, there's a piece here that goes
It's pretty wild.
all the way around. And then it's
So anyways, yeah, 2 poles and a magnet. And this is really, one of the reasons why it just doesn't, it doesn't work out so well. Okay. In particle physics, a magnetic monopole is a hypothetical elementary particle that is isolated magnet with only one magnetic pole, so all north or all south. Right? So the key words here that they're using to define what a magnetic monopole is elementary particle, meaning it cannot be indivisible. It cannot be divided in any way, shape, or form. So, by that strict interpretation, there is no such thing as a magnetic monopole. I can tell you that right now. If you really want to understand magnetic fields, you need to go back and look at my video I made not too long ago explaining magnets. Really break it down for you. If you watch that video, it's a long one, but it's a goodie. You will be among the world's foremost leading authorities on magnetic fields if you watch that video from start to finish, 100%. Uh, so, but the reason why magnets cannot have a monopole is because, by definition, a magnet doesn't really exist. It's a secondary afterglow effect of a monopole charged electric field that is moving. So, and the way that it's moving, determines on where the North Pole and South Pole is going to be. So, by definition, the very creation of the magnetic field gives it a North and a South Pole. Can't break it apart. And then when you try and break magnets apart, North and South make smaller ones. Oh, well, you just get smaller North and South poles. That's it. That's all you get. So there's a lot of people do a lot of research on magnetic monopoles. This is something that theoretically, I guess you could argue, could exist according to general relativity, or my bad, maybe not general relativity, but quantum mechanics, I believe, is the theory that kind of really delves into that. Um, with this right here. Ooh, Maxwell equations. But yeah, the Dirac string. Dirac's guy that kind of single-handedly launched quantum mechanics, and basically. Oh, hold on. Well, apologies for that interruption. Got a phone call, and I never get a phone call, so I thought I'd answer it. But living in Asia, you never know what they're trying to tell you on the phone. It'd be what it be. So, according to Dirac, he came up with this hypothetical mathematical representation of like monopoles. And he calls like Dirac strings, and if they're infinitesimally, for infinitesimal paths, group element is close to identity, or for longer paths, group element is successive part of infinitesimal groups along the way. So yeah, basically, if you go into infinities, you can have a magnetic monopole. But as any one of you know who've been following my channel, there's no such thing as infinity. It's just a mathematical concept. It's made up by humans. It doesn't exist. There's no infinity anywhere in the universe, anywhere, ever. Everything is limited. Everything is finite, even if it's astronomically huge numbers we're dealing with here. That's just the way it is. But funny thing is, if we have Maxwell equations, this right here mathematically says you cannot have a monopole because the curl whatever of a magnetic field equal to zero. Because it's equal to zero, cannot have a monopole. But Maxwell made that rule up because it fit the observations. He could have easily not set that to zero, and now magnepoles are real. You just have to find one to justify the observations of your math, which so far no one has. So, ergo, magnetic curl set to zero, or not curl, but change. No, there is no monopoles because of this. Right here is what you need to know. This right here is the equation. It basically pushes it out. And we look, here's, some research going on in magnetic monopoles, theoretical motivation predictions. Concept of monopoles is strongly supported by theoretical frameworks. Dirac's theory suggests that monopoles could explain charge quantization. And the blah, 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 monopoles. They just get into more crazier and crazier mathematics and adding more dimensions, and who knows what they're doing to make the math work out. But remember, math is not always real. Sometimes it's made up. So I always have to make sure that it collaborates with existing measurements. And monopoles does. None of this math does. None of it does. But recent experimental approaches involving squid-based techniques detect magnetic flux noise in materials like whatever that is, which could indicate the presence of monopole-like excitations. That's interesting, but that to me sounds more like a vortex, a magnetic vortex is being created, which can indeed have a monopole. But once again, you have to remember it's not a magnetic field, so to speak, or definitely not a particle. It's a event that's occurring magnetically that's creating what appears to resemble something, but it's not a monopole through vortexes. And as you know, electrons and quarks are vortexes too, and I guess that's the reason why they can be monopoles is because they're vortexes, the way they operate. Vortexes can be monopoles. So if you have vortexes of magnetic fields, you can have monopole-like excitations. So the research seems to imply, but they're not sure yet. But I'm going to show you how to do a magnetic monopole right now, bro. Because that's right, yours truly, Dynamic Gravita, has made one. A magnetic monopole. Behold. I know it doesn't look like much, and it really isn't. It is just a ball of aluminum that I made, and then hot glued a bunch of itty bitty magnets together that are all facing the same direction. And it is technically a monopole. I mean, this one really isn't because it's a shitty one. Because as you can tell, the glue I used was not strong enough to hold these magnets together under the stress that they're under. So there's a lot of cracks. There's a lot of things that are not perfectly engineered the size, which means now you're going to have uneven distribution of magnetic fields interacting, seeping out, and changing, and you're gonna have all sorts of crazy. There's a lot of magnets in here that when it was being hot glued, they flipped and then got glued the wrong direction. Go figure. So I tried with what I have available, but unfortunately I couldn't get it. If I had a perfect ball to start with and interlocking hexagonal magnets that were the right size for that ball, and maybe a really strong glue like super glue, could probably make like a really, really legit, magnet monochrome. Wouldn't be perfect, but it'd be very, very close. This one, as you can see, like as I put it on here, it will roll because it is pushing up against it. Like I can feel it right now. It is pushing most wherever I have this thing. But as I can see, there's spots in it where the magnetic field has been flipped by a magnet that was, that flipped during the process, put it on there, or ones like this that are, just not very even, or just large gaps that allow it to stuck. But it should be repelling mostly. And it does repel mostly. I know you can't feel it like I feel it, but it is repelling on about 90% of this. And then the other 10% is actually attractive. And that's one of the qualities of magnets. When you put them all together like a giant amalgamation, if the magnetic fields are not perfectly lined up and forced together in a way that will create a coherent magnetic side, then you get like an amalgamation. I forgot what the field is called, but it's just basically a bastardized field of all different polarities, and it basically cancels out. It's a magnetic property where it's magnetic in all directions, but it's weirdly magnetic in that it will attract both North Pole and South Pole because magnetic fields are blended together so much, and there's so much going together wiggle room that's the way it works. But technically, if you were to do this proper, this would technically be a magnetic monopole. And you could scale this up or down, and you could have various things you could do with that. Now, it wouldn't fit the definition of magnetic monopole by particle physics, where it's an elementary particle, it's indivisible, that would have all just, north or south magnetic fields extending in all directions. But it does fit the property side And you can make this weight better too. Like I saw these, I was really tempted to get these, but I mean, this price is kind of expensive. Like 1,000 baht, it's like $33, and you would have to have like two of these because they're split 50-50. I think if we look right here, look at this. These are most of these magnets are not the way you need them to be. It has to be a magnet made specifically for like an arc magnet. I don't know what an arc magnet is for. I think they're used for like turbines, wind turbines. Yeah, wind turbines. Okay, yeah, magnet for generation wind. So you would have your rotor in here that spins by the winds, and that would generate electricity because it's constantly flipping the magnetic field from north to south. You see it north to south. And does it show how it fits together here? Probably not. It never does. But I know this one does. Okay. This one, you can see how they all fit together because they're alternating the magnetic polarity. So one bit will have the north on top and the next one will have the south on top. So that's why they will fit neatly together. If you were to make this a true or a magnetic monopole, so you would have to buy like two of these, right? Because half of them are north and half of them are south on whatever side you want. So you'd have to get two of them together, and then you would have to force them together because they wouldn't want to fit together. They would be going against their magnetic momentum and their fields. But if you were to force them together, like super glue, some strong binding agent, or bind them together somehow, not a problem. And then what you would have is a circle for this one that would be all south poles on the perimeter and all north poles on the interior, or vice versa, however you want to make it. So no matter what angle you come at this, as long as these magnets are made proper, like this, like as long as they are truly magnetized like that and not kind of catty corner or whatever, then you will have a monopole circle for this. Now, for like a sphere, you'd have to get a different configuration of magnets. You'd have to have probably like hexagonal magnets that you would just fit together, interlocking until you fit an entire sphere together. Yeah. And of course, you have to bind them together. But this is why. This can be done. I'm telling you guys, this is possible. This can absolutely be done. You can create a magnetic monopole. It won't be a particle physics magnetic monopole, but it will be a magnetic monopole by every other definition you can come up with, relatively speaking. Besides, it's not indivisible. It's really good. I'm kind of into this because if you have a magnetic monopole, you can start doing some weird things. Like you can start hovering and levitating things without having to worry about the magnet wanting to swap its orientation, because any orientation it has is going to have the same pole. So as far as things like levitation or creating maybe some sort of like joints, to create like something to transfer, force. This could be useful for a lot of different things. I don't have time to play with it too much. I got too many things on my plate right now. I'm still working on trying to generate a magnetic field, and I have had some odd results. So trying to hash through that, trying to figure that out. It'd be what it'd be. But anyways, short episode today, guys. I just wanted to, show you that just because quantum mechanics, actually quantum mechanics says it's possible, just because, particle physics says that it's impossible to have a magnetic monopole, you can absolutely do this. There's for every vice, there is an anti-vice, my child. Okay? You must remember that. There is always a way to make pig flies. The question is, how much effort do you have to put into it? There's always a way to make a pig fly. Put that bad boy in a cannon. Light that thing. Or yep, there you go. You know, put him attach him to some, jet engine and some wings on him. He'll go. That pig will fly. That pig will fly. So there's always a way to make things happen. You just have to be willing to look outside the box and to understand what parameters you're willing or can change around to get the desired result. But anyways, on that, I'm going to dip out. And I wish you have a beautiful day. And until next time, stay safe. Adios, muchachos.
Like, subscribe, submit.